Hello everybody, we're going to be working on the 2.4.3 quiz for Algebra 1, and as we have been doing, we're going to be using the checkup problems for this section, so we're on the 2.4.2 checkup. We're going to talk about accuracy and precision first real quick. Accuracy is how close you are to the correct answer, right? So if you're accurate, that means you're right. Now precision is how detailed you are, or I think detail is the best word. It's how detailed you are. So looking at this first question, we have 4 thermometers, and they're measuring the temperature of a freezing pond. And we want to know what is the most accurate. Well, the water freezes at 32 degrees. So we know 32 degrees is our correct answer. So the first thermometer measured 34 degrees. So it is off by um, 2 degrees, and the thermometer rounds to the nearest one, right? So there's no decimal there, so it's not very precise. It just goes to a whole degree. Now the second thermometer gave us 33.5 degrees. Now that's not accurate, right? It's off by 1.5 degrees, but it's a little bit more precise because it has that decimal. Because if with the first thermometer, um, it could have read 33.5 as well, but then it would round up to the 34 because it is not very precise. It rounds to the whole number. Now the third thermometer read 31.5 degrees. Now we're getting close to being pretty accurate, right? So if 32 degrees is what we're looking for, we're a half degree off. And it's kind of precise, right? Because it has that first decimal. If we go back to that first thermometer that gave us a reading of 34 degrees, the third thermometer, if it had that setting, would tell us 32 degrees because that 0.5 would round us up. And now the fourth answer is giving us 34.587 degrees. Now, obviously, that's not very accurate, right? Because we want 32 degrees, and this one's off by the most. However, it is precise. It is very precise because it goes to 3 decimal places. That means if we can calibrate this thermometer to give us an accurate temperature read, it's probably going to be the best thermometer for us to use, right? Because it's going to give us the most detail. And now, in terms of the question, which thermometer or temperature is the most accurate, is going to be that 31.5. It is the closest to 32, but it's not the most precise. So the second question, a digital thermometer measures the temperature of a freezing pond is 34.587. We kind of talked about this. So this thermometer is precise, but it is not accurate, as we discussed a couple seconds ago. Question 3 here. An odometer measures the mileage of a car to 1/10 or 0.1 of a mile. Circle the measurement that shows an appropriate level of precision for this odometer. Well, if it tells us that it measures to a 0.1 to the 10th digit decimal, that means we're looking for the answer that has 1 decimal place. So between 60 and 70 miles isn't very precise at all, right? It's giving us too big of a range. 65 miles isn't precise to that 10th digit. 65.8, bingo, that's going to be our answer, right? Because it goes to that 10th digit. Now 65.792, now this likely is more precise, but it's not what this question is asking. This question wants the one that's precise to the 10th digit. All right, now this next stuff, we're going to go ahead and do conversions, unit conversions. So our first one we're going to do is we're going to go from 2.6 miles to yards. So I'm going to take, go ahead and choose blue. So first thing I'm going to do is I'm going to write a fraction. So I'm starting with 2.6 miles. All right, so I have 2.6, and I'll put mi for miles. And I'll put it over 1. Erase this excess fraction. So I have 2.6 miles over 1. And now I'm going to multiply by another fraction. All right? And that fraction is what I'm going to fill in. Now, the first thing I need to know is since I'm getting rid of miles, I want to get rid of miles. I have miles on top here, so I'm going to put miles on the bottom here. And the reason why I do that is because this unit and this unit will now cancel. So I'm getting rid of miles. Now, on the checkup problems, it tells you that there are 1,760 yards in 1 mile. So we have 1 mile, and that's equal to 1,760 yards. So this 1,760 yards over 1 mile, that's a single unit, meaning they are each equivalent to each other. All right, so we're changing from miles to yards, but this fraction is essentially equal to 1. So I make sure the miles are on the bottom because I want to cancel those units. and the numbers are all the same. I want to end up with yards, so yards is on top at the very end. And then I'm just going to do 2.6 times 1760, and then I'll have yards as my unit. And I'll just multiply that, and that's my answer. All right, I kind of quick, like, hey, it can't be that simple, right? Let's go back and set up the next one. So we have 77 centimeters into feet. So I'm going to do the same thing. I'm going to make a fraction, so 77 centimeters, and I'm going to put it over 1. The checkup problems tell us that there are 1 inch for every 2.54 centimeters, and then there's 1 foot for every 12 inches. So for me to go from centimeters to feet, I need to take a pit stop at inches. So I'm going to set up a next fraction. I want to get rid of centimeters, so centimeters has to go on the bottom. And then I want to go to inches, right? Because I can't go from centimeters to feet, right? They don't give us that conversion. But they tell us we can go from centimeters to inches. So I'm going to put inches on top. And now 1 inch is the same as 2.54 centimeters. So it's okay to have a bigger number, bigger than 1 number on the bottom, in the denominator. That's fine. And now these centimeters cancel. Now my final unit, right, is an inch. Is that what I want? No. I want to end up with feet, so I need to get rid of my inches. So I make a new conversion. I want to get rid of this inch. Well, it's on top, so I got to put the inch on bottom. And now I can cancel out those inches, those units. And now, since I want to end up in feet, and I can go from inches to feet, I put feet on top. I know there's 1 foot for every 12 inches. So I have 1 foot, 12 inches, right? We know those are equivalent. 1 inch and 2.54 centimeters. We know those are equivalent. So I'm able to cancel my units, and I'm left with feet. So this is going to be 77 feet divided by 2.54 times 12. And I guess probably a more proper way if I'm being a little bit better here. It would be 77 divided by 2.54 times 12, right? You can use your calculator for that. And that answer would be the total number of feet that are in 77 centimeters. All right, so I just set up my initial unit. I then try to cancel that first unit out. So I want to cancel centimeters out. And I get to inches. Well, inches isn't where I want to end up. So I need to go to feet. Well, so I got to cancel inches. I do that by putting in the denominator. And I end up with feet. All right, so we want to convert 10,000 seconds into hours. So my first step is what? Yep, we need to write our first unit. So I have 10,000 seconds over 1. Now, if I'm going to seconds to hours, what is in the middle? Minutes. All right, so I'm going from seconds to minutes first. Well, if I want to get rid of seconds, that needs to go on the bottom. And then I want to go to minutes, that needs to be on top. And for every 1 minute, there are 60 seconds. And that cancels my seconds. And right now, I'm in terms of minutes. Well, do I want to be in minutes? No, I do not. I want to be in hours. So I go ahead and put the minutes on the bottom so I can cancel them. I put hours on top because that's what I want to end up with. And then for every 1 hour, there are 60 minutes. So for this one, my minutes are canceled, my seconds are canceled. So I have 10,000 divided by 3,600. And whatever that answer is, would be the number of hours there are in 10,000 seconds. Now this next one's going to be a little bit more complicated. I'm going to go from 45 miles per hour to kilometers per minute. And the checkup problems tell me that 1 mile is equal to approximately 1.6 kilometers. So I'm going to start the same way. I have 45 miles. Now instead of just putting a plain old 1 down there, I got to put a 1 hour, right? Because it's miles per hour. And now so if I'm going from miles to kilometers, I have a singular conversion. So I just have 1. So I can end up with kilometers. That goes on top. My miles go on bottom, and that cancels. It told me that there's 1.6 kilometers per mile. All right, so that got me in kilometers. Kilometers is now my unit, but I'm still kilometers per hour. It wants me to go to minutes, so I need to do another conversion. This one's going to be a little bit different. Now I want to get rid of the hour, which is starting in the denominator. Right, normally we've been canceling stuff that starts in the numerator. Now it's starting in the denominator, so I need to put my other one in the numerator, so they cancel. And since I'm going from hours to minutes, is what we're looking for, I put the minutes on the bottom. And then I know that there's 1 hour for every 60 minutes. So that cancels my hour. And what I have here is 45 times 1.6 divided by 60. And then I have kilometers per minute as my unit. So for these unit conversions, what I'm trying to do is I'm trying to cancel numerators and denominators, whatever they may be. So I'm trying to get rid of miles. I have to make sure there's a mile in the numerator and the denominator so I cancel. And then each fraction I create must be equivalent. It must be a singular unit. 1 hour and 60 minutes is talking about the same thing. 1.6 kilometers and 1 mile are talking about the same thing. That'll be the same exact distance. If you ran 1 mile, it'd be the exact same as running 1.6 kilometers. If you worked out for 1 hour, it's the same as working out for 60 minutes. So we're able to, because they are equivalent, change their units freely as our fractions. And then we are able to just simply cancel out and move everything. So here we want to go from centimeters to feet. Well, we needed to stop at inches. So I put centimeter on the bottom to cancel that, and I have the inch on top. And this 1 inch for every 2.54 centimeters is a constant. And then I want to get rid of my inches, so I got to put the inches on the bottom. I want to end up in feet, so I put the feet on top, the inches canceled. And then there's 1 foot for every 12 inches. So this unit is correct.